All right, we left off with this problem, and the bell rang right when I was going over the answer. Now, these problems can be a little more tricky if you are not paying attention to the finer details, and I almost fell into that trap too, so I want to make sure that we're all clear on this. If you look at the previous problem that we did, we converted 3.5 moles into molecules, and so we had to do 3.5 times Avogadro's number, which I was a little busy with everything going on here, so I'll ask you guys that tomorrow as you walk in. What is Avogadro's number? You need to know it. We did 3.5 times 6.02 times 10 to the 23rd, and that got us 21.07 times 10 to the 23rd molecules. However, you should know that 21.07 is not the appropriate scientific notation. So we have to shift the decimal 1 to the left to make it 2.107 times 10 to the 24th. But then we have to consider significant figures. 3.50 is only 3 sig figs. So your answer needs to be 3 sig figs. Well, right now that's 4. So we made it 2.11 times 10 to the 24th molecules of sucrose. That would have been your correct answer. And so the next problem is just reversed to see if you're doing the math properly. And so you do 2.11 times 10 to the 24th. Hold on one sec. You do 2.11 times 10 to the 24th. Technically, you would multiply it times 1. But for all of you math whizzes, do you really need to bother doing 2.11 times 10 to the 24th times 1? No, because it's still going to be the same number. So here's what you do. And this is going to be a question I'm going to ask you from Unit 1, way back in September. When you are dividing numbers that are in scientific notation, what do you do with the exponents of the scientific notation, Arshan? You subtract them. That's the part that I almost left out. So you're going to do 2.11 times 10 to the 24th divided by 6.02 times 10 to the 23rd. So let's do the easy math first. 2.11 divided by 6.02. That gives you 0.350. Now, don't forget this part. Jade, what is 10 to the 24th, key part being 24, minus 23? 1. 24 minus 23 is 1. So 10 to the first. And what is our unit of measurement? Molecules canceled out. So what is left? Moles, that's right. Okay. Is our answer in proper notation? No, it isn't. You need to have at least one digit, not named 0, on the left of the decimal. So we're going to shift that decimal 1 to the right. So we're going to have 3.50 times 10 to the what? Second or 0? 0 moles. Now, in case you didn't know, 10 to the 0, the number is not moving anymore. So you don't really need to include 10 to the 0 anymore. Your answer is 3.50 moles. And so the thing that I think, as a former chem student that used to struggle on his own, the thing that you guys may not remember is that when you have numbers in scientific notation and you are dividing, you have to subtract those numbers, right? Max, 10 to the 24th, the key number being 24, minus 23. 24 minus 23 is 1. And there, that is, right there. But then you have to remember that you have to put your numbers in proper scientific notation. Shift the decimal 1 to the right. Instead of being 0.350 times 10 to the first, it'd be 3.50 times 10 to the 0, which is no scientific notation is needed. All right, and that gets us through that. Last night, I attempted to post some homework for you guys, but I was having a little trouble with Canvas, but those problems have been corrected. So you have a homework assignment, which is basically this material here. I can work out number 1 with you guys to just kind of get you on a roll. So let's switch over to that momentarily. Bring that assignment up. So let's see, if you go to Canvas, Oh, looks like I might be having some difficulties here. Let's try it again. Canvas might not be open. Come on, there we go. Okay, perfect. So you go to chemistry, go to assignments. Let me share this with the video. Okay. Actually, that's my AP class. Oh no, wrong class. There we go. All right, there's your assignment. Due by 11:59 tonight. That doesn't mean you have to wait till 11:55. It's due by that time. All right. If I go to, let's see, homepage, I guess I left that out. I'll fix that. It's not on the assignment, but it's not on the assignment, the worksheet, but I'll fix that. Let's go here. Assignments. There we go. Okay. Moles to particles worksheets. Perfect. There's your worksheet. It's in a PDF, so you really can't download it and write on it unless you have a touchscreen like I have, like a tablet. So the thing I want you to do is print it out, write on it, and if you're able to scan your answers back to the computer, that's great. If you don't have that technology, like a scanner at home, then you have to use your phone. I want to remind you that cheating is going to get you nowhere. This is where the rubber hits the road and you actually have to go through the motions. If you don't get this practice, the test is going to be a disaster for you. This is practice. This is 10 points. It's not that much. Cheating is not going to make your grade awesome. But when that test comes, and if you cheated, that test is going to destroy you. So don't do it. Don't cheat. Let's check out number 3. Determine the number of representative particles in each of the following. Shell factor labeled method. So let's just do this one. I'll work this one out with you guys. It says 0.25 moles of silver. So let's see if any of you can tell me. Is silver an atom, an ion, a molecule, or a formula unit? That's not one of the choices. An atom. So your representative particle in 3A is going to be atoms. So we need to convert it from moles to atoms. So we're going to start with 0.250 moles of silver. Silver's symbol is Ag. You then have to set up your conversion table. We're going to convert it to representative particles. So what conversion are we going to be using for this entire worksheet, Arshawn? 1602 Whose conversion is that? All right, so you're going to be using Avogadro's number. Max, 6.02 times 10 to the 23rd representative particles is equal to 1 mole. What am I going to put on the bottom of this conversion table? 1 mole or Avogadro's number? Avogadro's number. If I put Avogadro's number on the bottom, Max, I'm going to put, let me show you. Is moles and atoms like terms? No. So can they cancel out? Okay. Guys, if you were here yesterday, I told you this is going to be the number one mistake that will be made by most of you, if not all of you. That mistake is you're going to put the number or the wrong number in the wrong spot. So you will have to work through those mistakes a few times. Sometimes you have to learn the hard way. This right here is moles. Hold on. Whatever. That's moles right there. Moles and atoms don't cancel out. So that is not it. Try again, Max. Avogadro's number's on the top. Avogadro's number's on the top. So what's on the bottom? 1 mole. That's right. 1 mole of silver is equal to Avogadro's number, which is going to be on top. Now, Max, does moles of silver cancel out?
Yeah.
Yes. Good. So this is a multiplication problem. So get out your calculator. 0.25 times 6.02. I got 1.505 times 10 to the 23rd. 1.505 times 10 to the 23rd atoms of silver. Now, listen carefully to my question here. Is our scientific notation in the proper format? Yes. Here's my next question. Do we have the correct number of sig figs in our answer? No. Here's the second most common mistake. Trust me. How do I know how many sig figs to use, Mr. Thorson? I mean, do I look at the known value or do I look at the conversion? Never look at the conversion for your number of sig figs. Always look at the known value. The known value is 0.250. That's 3 sig figs. 1.505 is 4 sig figs. How do we get that reduced to 3? We keep the 1. We keep the 5. Now we need to look at that, or wrong symbols here. We keep the 1. We keep the 5. What do we do with that 0? Well, does that 5 to the right of the 0 round it up to a 1 or keep it a 0? All right, so your answer is going to be 1.51 times 10 to the 23rd atoms of silver. Keep in mind a few things. One, you have to make the like terms cancel out. So whatever unit of measurement is in your known, you need to have the common unit of measurement on your conversion on the bottom right here. Second thing, you need to be sure that you put the correct number of sig figs, you have the correct scientific notation, and lastly, remember what I told you. If you were just to write 1.51 times 10 to the 23rd, you get half off. You have to write atoms of the substance, atoms of silver. You have to write the units of measurement. And again, for some of you, you're going to have to learn the hard way by making the mistakes and learning from those mistakes. I'm not going to bail you out on these and do you a little favor by saying, oh, I'll just let it slide this time. That's not how it's going to go. So you need to pay attention to writing the units of measurement. It's probably the first time in your life you've had to do that in a math type setting. But there's first time for everything. So that is your homework. It's 2 pages. You just have to answer number 1, number 2, number 3 has 4 problems, number 4 has 4 problems, number 5 has 4 problems. And that's due by 11:59 tonight. Okay? Let's get back to the material. And we're going to start section 2 today, okay? So section 1 was just measuring matter and learning particles to moles. Today is going to be mass and moles. Section 9.2, mass and the mole. So a quick recap. A mole is the SI unit for the amount of a substance. The abbreviation is MOL, and in Avogadro's conversions, 1 mole is equal to 6.02 times 10 to the 23rd representative particles. A representative particle can be an atom, an ion, a molecule, or a formula unit. That's on a case-by-case basis. What I would like you guys to do now is either get out the periodic table that's underneath your desk or get out the periodic table that you made in the first semester. Yeah. Go ahead. Okay. So here we go. The mass of a mole. Every element has a different atomic mass. So to prove to me that you guys can identify the atomic mass, here's what I want you to do. I'd like you to scan the periodic table. I'm going to ask each and every one of you to identify an atomic mass of my choosing. All you have to do is find the element and tell me what it is, rounded to the nearest whole number. So no decimals, all right? Let's get to it. Kevin, I want you to tell me the atomic mass of carbon. From now on, I want you to say AMU, which stands for atomic mass units. Carson Dye, thorium. TH. Bottom left. 90. Nope, that's the atomic number.
I don't see it on here. Oh, 232.
Brennan, hydrogen. One what, Brennan? Don't be the first person not to say it. Jade, neon. Max, uranium.
238.
Good. Let's go to Cheeseman, helium. Mm-hmm. Atom, eeny, meeny, miny, fluorine. Yep. I'm taking your word for it, guys. I'll definitely know if you're not saying the right one, but for most part, I'm taking your word for it. Nicole, actually, no. Timothy, potassium. Okay, let's go to Nicole, carbon. Actually, we already did carbon. Let's do calcium. Let's go to Arshan. Argon. Argon for Arshan.
48.
48?
40.
I thought calcium was 40.
Argon?
They're both 40. Okay. It is what it is. Let's do aluminum for Derek.
27.
Okay, for Kendall, we're going to have gold. AU. Gold. Right? Somewhere in the middle. Element number 79. All right, we're going to stop there. I did say every single one of you. I think 12 is enough. You're looking at the mass number, not the atomic number. So those are all the atomic masses, and you're going to need to be able to identify those in order to do our next step, which is going to be a big one. It is called molar mass. This is a vocab term. Molar mass is measured in grams per mole. Yes? No, I said every element has a different atomic number.
Oh.
Okay, molar mass is measured in grams per mole. That's a derived unit. To keep you guys understood, Mole is always going to be 1 mole. Carson, when you go to Disney World, you're going to be driving to Orlando at about 80 miles an hour. How many miles? In how many hours? How many hours? When you're driving 80 miles an hour, how many miles are you going to cover? In how many hours? 1 hour. Okay? 1. When you are going, let's see. Jade, how many classes do you have in one school day? You have 8 periods. You have 8 classes? You have 7 classes. So think of it like this. You have 7 classes per day. How many classes? How many days? The second number is always 1, everybody. The second number is always 1. The first number, which is going to be grams, it can be 1 or multiple. It could be 1 gram per mole. It could be 1,000,000 grams per mole. But the point I'm trying to make to all of you is that when we're doing molar mass, it's X grams per 1 mole. 1 mole, 1 mole, 1 mole. Molar mass is the mass of 1 mole of a pure substance. And once again, it is measured in grams per mole. So for carbon, we say the molar mass is 12 grams per mole. You have to refer, this number that I got is the atomic number. That's where you get it from. Whenever I ask you what is the molar mass of any given element, all you have to do is look at the atomic number. So I'm going to get to the other half of the class, starting with Colby. Colby, I want you to tell me, what is the molar mass of lithium? So to answer that question, you're just going to look at the atomic number. What number do you see? What? No. Oh yeah, I do mean atomic mass. I apologize. Thank you for catching me. So for lithium, look at the atomic mass number. What is it?
3.
No, that's the atomic number.
7.
7. And you're going to say 7 grams per mole. Go ahead.
7 grams per mole.
That's right. You guys need to be sure you know the difference between the atomic number and the mass number. Scout, let's make it easy for you all. Sodium, what is the molar mass?
23
Grams per mole. Okay. Let's go to Juliana here. Okay, Juliana, how about silicone, Si? How many grams per mole? 28 grams per mole. Good. David, how about phosphorus?
31 grams per mole.
31 grams per mole. Let's go to Alyssa. Let's do chlorine.
35 grams per mole.
35. Now, chlorine is 35. Does your periodic table say 35.4 or 35.5?
4.
Okay, fair enough. 35 grams per mole. Nick, let's go to copper, Cu.
64 grams per mole.
64 grams per mole sounds good. Emma, how about francium, bottom left corner?
223 grams per mole.
223 grams per mole. Let's go to John. Xenon, far left. Or far right, actually. Xe. 131 grams per mole. Let's go to the next student. Kayla, bromine, Br. How many grams per mole?
80 grams per mole.
80 grams per mole. And last one, Francis, let's try titanium, element number 22, fourth column. Ti.
48 grams per mole.
48 grams per mole. So when you guys are looking for the molar mass of any given element, you need to look at the atomic mass, okay? All right, now, how do we actually use molar mass? Okay, I'm going to give you a word problem. You're a jelly bean dealer. Wait there. You sell jelly beans by the dozen. You buy jelly beans in bulk and realize it is too much work to count jelly beans by the dozen, so you decide to sell jelly beans by mass. 12 jelly beans equals 1 dozen. That's your first conversion. And you determine that 1 dozen is equal to 35 grams. You have a customer who wants 5 dozen jelly beans. How many grams is that? So a customer wants to buy 5 dozen jelly beans. How many grams of jelly beans? Yes, Derek?
So when we're doing the molar mass for the element, do we always just have it?
Unless I tell you otherwise, yeah. Okay, so let's see how well you guys are doing this dimensional analysis, which is a fancy way of saying converting. What is your known value in this problem? Not your conversion, your known value. David? 5 dozen is correct. Okay, what conversion do we want to use? 12 jelly beans equals 1 dozen, or 1 dozen equals 35 grams, Arshawn?
1 dozen equals 30
We want to do 1 dozen equals 35 grams. Where are we going to put 1 dozen, top or bottom?
on the bottom.
Why on the bottom?
Because it's the same unit as the known value.
Because it is the same unit of measurement as the known value. So you're going to cancel out dozens and dozens, and 1 dozen is equal to how many grams?
35.
35 grams. Dozen cancels out. Is this a multiplication problem or a division problem? This is multiplication. 5 times 35 is 175 grams. There's another example of dimensional analysis, but in this case, guys, you're using mass. You use mass instead of particles. Yesterday, we did atoms and ions and molecules. Today, we're doing mass. So now, let's do an actual chemistry problem. We're not talking about jelly beans in here. We're talking about elements in molar masses. So here we go. You need, here's an example problem. Plenty of worthwhile practice here. You need 3.00 moles of copper. Convert moles of copper to mass. Okay. First off, I'm going to highlight your known value. Adam, can you tell me what is my known value in this problem?
3 moles
You got it. 3 moles of what?
copper.
Very good. That is my known value. Nowhere in there does it give you a conversion. These are things that you guys are going to be figuring out on your own. So the element that we are dealing with here is copper. Are you going to be allowed to have a periodic table at your test? Yeah, I would be a sadistic psychopath not to let you use a periodic table on a chemistry test. I'm not that evil. So you need to look at your periodic table and you need to find the molar mass of copper. Tell me what it is. Round it to the nearest whole number. Arshawn?
64 grams per
64 grams per
mole.
mole. The way that you can actually write that is 64 grams is equal to 1 mole. Or 1 mole is equal to 64 grams. There's 2 different ways you can write it. Yes, Kevin?
Do we have to call a sig fig?
You do, but here's what I want you to keep in mind. You do not consider the number of sig figs in the conversions, okay? Only these are your conversions. I'm going to highlight them in green. Those are your conversions. The 3.00 is what you're going to focus on the number of sig figs. How many sig figs is in 3.00? 3. So your answer needs to be in 3. All right, don't worry about the conversion factor. Okay, so as Adam said, 3 moles of copper is our known value. So let's do it. Max, what do I put on the bottom of my conversion table? 64 grams of copper or 1 mole of copper based on what the known value is?
1 mole.
You got it. 1 mole of what, Max?
Copper.
That's right. And on top, we're going to put the mass, 64 grams. So Max, is this a multiplication problem or a division problem?
Multiplication.
Yeah. 3 times 64. 192. Ooh, I love doing this. Hello? Hi, this is Mr. Thorson. I'm great. How are you? Are you calling for Carson? No, here he is. I'm kind of calling him out because he's supposed to have his phone off, and now he's grinning. Does he know? Oh, you're supposed to be at home, Carson. That's what your mom says. Well, I'm glad he came today because we're doing a lot of important stuff in chem. I'm glad he's here. Are you learning something today, Carson?
Yeah.
Yeah, he said he's happy to be here. He's safe for now. Sure. Bye.
Oh, you guys can stir.
Hey, by the way, your mommy loves you. All right. That's 192 grams of copper. Now, let's see if you guys can take this one step further. I want you to put that in scientific notation. Technically, where's the decimal right now? You don't see it, but where would it technically be? After the 2. Can you put it in scientific notation for me and keep the correct number of sig figs? What would it be?
19.
No, not 19. 1. 1.92 times 10 to the what? Second grams of. Ah, there you go. Either one will be fine. Either one will be fine. All right. Let's do another. Ooh, I just thought of an even one. Oh, this is gonna hurt. No, it's not really hurt. You guys will be fun. Okay, yes, Carson.
I'm confused, like, on the exponent, you know, how before you have like 10 to the 23rd,
Mm-hmm.
and now it's like 10 to the
Because you were doing atoms.
Oh,
This is grams. 2 totally different units of measurement. Okay, we're going to take this one step further with my favorite element, thorium. All right, here we go. What? You're going to miss this one. You got to go. You got to go. All right, let's see. You need, let's see. Give me a second to think this out. I want to make this a good one. Okay. You need 5. No, wait. You need 50 grams of thorium. you have, no, don't write anything until I'm done. I'm trying to think this out, on a whim. Okay, I got it. You have 50 grams of thorium. Convert to atoms. There we go. Oh, I'm evil. Okay, now, have we done a conversion so far in the last 2 days that lets you go back and forth between mass and particles? No. The answer is no, we haven't. Okay, so first off, picked on Adam, I picked on Max. Let's pick on Alyssa. Alyssa, what is my known value here? Of Thorson. Thorium. That's your known value. Now, you guys had two conversions here. So Derek is correct in that you have not been given, and there is no conversion to go straight from grams to atoms. That doesn't exist. So this is going to be a two-part problem. You're going to have two conversions. Have you guys been given have you been made aware of a conversion to go, or excuse me, that involves mass?
Yes.
Yes. What conversion do we call that? Molar mass. Very good. We need to find the molar mass of what element? Thorium. All right. So for thorium, what is the molar mass?
232 AU.
Okay. So we're going to say 232 grams per mole. You can think of that as 232 grams equals 1 mole, or 1 mole equals 232 grams. Remember that you can use either one. Okay, great. But we don't have a conversion for atoms yet, or do we? Have you done a conversion that involves atoms? Yes. What conversion is that? Avogadro's number. One mole is equal to 6.02 times 10 to the 23rd. And we're dealing with thorium. Is thorium an atom, an ion, a molecule, or a formula unit? Atom. Or you can say 6.02 times 10 to the 23rd atoms is equal to 1 mole. Carson, I really should have said, pay me $50, you never see your son again. First thing she said is, who are you? I have your son. Technically, I do. I have your son right here. He's sitting in class. All right. Okay. So you guys have two conversions. Let's get to solving this, and let's see what you can do. I don't want to just keep hearing from Arshawn or Nicole. I want to get different voices out there. What number should you start with always? You always begin with what number? Your known value. What is our known value? 50 grams of what?
Thorium.
50 grams of thorium. 50 grams of thorium is correct. Now, this is where you really need to, we're going to lay down some new neural pathways, which basically means you're going to start thinking. Which conversion should you implement first? The molar mass conversion from moles to grams and grams to moles, or the Avogadro's number conversion, which is atoms to moles or moles to atoms? Which one would be appropriate to use first, Carson? Okay, you are correct. I need you to expand on that. For molar mass, we have 232 grams of thorium equals 1 mole. Should we put 1 mole on top or on the bottom?
On top.
Correct. 1 mole of thorium, 232 grams of thorium. You are correct. Can you tell me why you chose to put grams of thorium on the bottom?
Because they wouldn't cancel out if they're in molar.
That's absolutely right. So if you cross them out, he's so far so good. However, what was the unknown value of the problem? What are we trying to find? We're trying to find atoms. If you stop right there, is your answer going to be measured in atoms? No. So we have to go further. We have to do another conversion. We're going to use the Avogadro's number conversion. Now, Carson Cheeseman, what number do I put on the bottom of this conversion? 1 mole of thorium or 6.02 times 10 to the 23rd atoms of thorium? Why did you choose 1 mole? That's right. 1 mole of thorium under 6.02 times 10 to the 23rd atoms of thorium. And just as Carson said, moles cancels out. Now, if you stop with your setup right here, is your answer going to be measured in atoms? Yes, it is. I mean, look, there it is right there. So let's do this one by one. What is 50? Hold on. What is 50 times 1? 50, okay? Then divided by 232. 50 divided by 232 is 0.215, which is actually 216. Now you're not done. What do you think you do after you do 50 divided by 232? You multiply. That's right. You times it times 6.02. And do you need to bother dividing by 1? No. So I'm going to highlight everything. If you just, that totally blew your mind. Follow this. Multiplication, division. Multiplication, division. And then you have your answer. So it's across, down. So it should be 50. And if you want to get technical, I'll do it all. 50 times 1 divided by 232 times 6.02 times 10 to the 23rd divided by 1. Your answer should be 1.30 times 10 to the 23rd atoms of thorium. You get that? Yes, Nicole. No, the 0 is a, how many sig figs? You're right. Okay, so I only used 1 sig fig. She's absolutely right. So we need to get this in the correct number of significant figures. How many sig figs is 50? 1. There's no decimal there, so it's 1. So what? How can we get 1.3 is just 1 sig fig? 1. That's right. 1 times 10 to the 23rd atoms of thorium. That's your answer. Okay. So what you just did is you did 2 different rounds of dimensional analysis. So the last thing I want to give you guys is a little key that you can refer to for the next couple weeks until your test. And it's a way to perhaps help you remember what type of math to do. Because I remember being in chemistry, all of you know how to multiply, all of you know how to divide. The trick in chemistry is knowing when to multiply and knowing when to divide. That's the catch. And that's where you can get a little twisted up. So I'm going to give you a little visual to help you hopefully figure all that out. Yeah.
If we just looked at atoms and write TH, would that be wrong?
Yes. All right, here we go. Oops, let me write that in red. Okay, so this is kind of the little cheat sheet here for the type of math to do. So if you think about it, we went from grams to moles to atoms. So from grams to moles, we divided And then from moles to atoms, we multiplied. And that's exactly what was done up above. We divided first, then we multiplied. If you're looking at setup, you divide first, then you multiply. That's going to be your little cheat sheet if you need to refer to it. But just as several of you demonstrated, you can figure it out if you just take it slow and take it step by step. And as you get better, you'll go faster. As with most things. Driving, running, pooping in the toilet. As you get better at it, you go through it faster. Right, Nick? All right, we're going to stop there.